us understand the topic armature windings. Generally, in three-phase winding of an alternator, wherein the voltage is induced, is called as armature winding. From the figure, we can define that one turn. So you can see here, one turn has two conductors. So you can see here the conductor 1, so conductor 2, conductor 1, conductor 2. So one turn completely makes two conductors. So what is a coil? So one coil has several turns in series. So here we have several turns, so such turns which are connected in series. Then what is a winding? A winding is nothing but several coils which are connected in series. So one turn is two conductors, one coil is several turns in series, and winding is nothing but several coils which are connected in series. So what is the importance of these windings? Generally in AC armature windings, AC armature windings are distributed in nature. So let us understand what is distributed and concentrated. Distributed is nothing but they are symmetrically distributed across different slots over complete circumference of the armature. Generally, your distributed windings leads to uniformity of sine wave. Here, heating effect is also quite uniform. Then there are open windings, that is, there is no closed path for the armature currents in the winding itself. What do you mean by that is, one end of the winding is joined to the neutral point and the other is brought out. Then generally the armature winding of a three phases are identical, but they are placed at 120 degrees apart. We call they are placed at 120 degrees electrical apart. And most of our AC windings are double layer windings because of the economical nature. Next, let us understand what is pole pitch or pole span. What is a pole pitch? When we compare the angular distance between centers of the two adjacent poles. So here, if we consider the angular distance between the centers of two adjacent poles and a machine is known as pole pitch. It is pole pitch. So generally it will be how much? It is equivalent to 180 degree electrical. So the pole pitch can also be mentioned in the terms of slots or conductor. Similarly, we have coil pitch. Just like your pole pitch, the two sides of a coil are placed on two slots on a stator surface. So here the distance between the two sides of a coil is called as coil pitch. Similarly, you have full pitch coil. What is full pitch coil? The full pitch coil is nothing but one pole pitch. So one pole pitch is also, it is called full pitch coil. That is, if the coil pitch is less than one pole pitch, then it is called as short pitch coil. So there are two types, one is full pitch and the short pitch coil. Now we can understand the relation between electrical and mechanical degrees. What is the relation between electrical and mechanical degrees? So let us consider here. So this is 360 degrees or one revolution. Now for a two pole machine, if it is two poles, for a two pole machine, one cycle of induced EMF is equal to 360 degree electrical, or one revolution is also is equal to 360 degree mechanical in nature. But for a four pole machine, it changes. Now what happens? Two cycles of induced EMF is equal to 720 degree electrical, wherein with respect to mechanical it is 360 degree mechanical. So what will happen here? One revolution, so theta electrical is equal to P by 2 theta mechanical. So what is the relation between electrical and mechanical? Means theta electrical equal to P by theta mechanical. Why it is so? So let us take a case, that is if it is theta electrical for 4-pole machine, that is theta electrical is equal to 4 by 2 into theta mechanical. Here what 4 by 2 is 2, theta mechanical is 360 degrees. So we will get theta electrical is equal to 720 degrees. So theta mechanical is angular, which are measured in space. Theta electrical is the angular measured in cycles. Hope you all understood the concept of different